Hello, and welcome to another Renoster review. Today we're going to be reviewing a project called Sealaska 1. This is an American carbon registry project registered with the California Air Resource Board Compliance Protocol. And let's see, it is ACR 324. I hope that this is going to be a quick video because, spoiler alert, the project failed. It has a 0 score. It's not additional, and the reason for that is that it is, it's essentially cheating the system. And real quick, the reason that it failed and the reason that it's cheating is that this is what the project boundary looks like. Now, the project itself, it takes place in the Alaska panhandle. It's really large. It spans, 400 kilometers from top to bottom, basically. But the project area, the official project area takes place on a bombed-out landscape, a landscape that is owned by a private timber company that has done its best to harvest as many trees off this land as possible. Most of these trees were harvested, within the last, I would say 30 years before the project, between the 80s, 90s, and 2000s. So why do we have a problem here? Well, looking at the project area, it doesn't look very normal, does it? It looks like a bunch of spaghetti squiggles. The reason for that is that under the existing protocol system, if you enroll your carbon project and you have less carbon than the average forest, you're not allowed to receive any credits. You don't get any credits until your forest meets the average. And the rationale for that is that we don't want people just cutting down their trees and then immediately enrolling for forest carbon and getting money back for those trees that are regrowing. Odds are, if you cut down those trees were going to regrow anyway. So that's the rationale behind that rule. On the other hand, for any amount of carbon that you have over the regional average, you get the difference. And so there's a huge incentive put out there by this protocol to maximize the amount of carbon that is on your project area. Basically maximize the average, get a higher average. Well, what do you do in a situation like this where they have clear-cut as many trees as they possibly could? Well, what they do is they enroll only the bits of the forest that they weren't able to clear-cut. And at Renoster, we call this gerrymandering. It's based on basically the kind of the political boundary gerrymandering that takes place in the United States. And it refers to drawing your project boundary in a way that results in you getting more credits. And so let's real quick take a look around at this project area and see why these trees weren't really at risk and why this project is cheating like this. On our first stop of the tour here, we see trees that are right along the coast. Now, there's a law in Alaska that says that you have to be something like 66 feet away from a permanent water body. Clearly, these trees are right along the coast, and they were left in place almost certainly to maintain that law. Likewise, we've got a similar situation here where it seems as if there was a buffer put around a stream. Now, the next thing that we see is we see the project area taking place, basically along this stream. The other reason that these trees could have been left is that it's potentially, a very steep ravine. So if you've got a slope that's 40, 50, 60% down, and there's only a couple trees to nab, then you're not going to put the effort in to go and grab those trees. It's just not going to be economically feasible. So people left these trees when they, this company that owns this whole chunk of land left these trees in place when they clear-cut the land. And that means that these trees really aren't at any risk. Moving right along, we can see that, in some cases, this project, it gerrymanders to such an extreme that there are cases in which they have literally, changed the project boundary just to circle a tree. So, they're, in this case, they've clearly extended the project boundary just to get this big tree right here. And they've extended the project boundary just to get this big tree right here. Why do they want to do that? Well, if you envision a project that consists of nothing but, one tree, then your per hectare carbon value is enormous, right? If you just have one tree and a tiny little area, then that means your carbon per hectare is in the thousands. And so that drives up their average for this project. So that's a real problem here, because a lot of these areas obviously not at risk, and what they're doing is they're manipulating a rule that was put in place specifically to avoid this kind of situation, where you've got a landowner who owns this entire chunk of land, really exploiting the shit out of their forest, cutting down as many trees as they possibly can, and then getting carbon credits as a cherry on top. And that's exactly what we don't want. And so Sealaska 1 is a project that is maliciously cheating. And I say it's malicious because there's obvious intent here to drive up their average by circling individual trees. And, based on that, we find this project to be just fundamentally unadditional. The other thing that I want to point out, there's a lot that we can do. There are instances in which tiny little islands with like a handful of trees are circled here. It's truly absurdity. The other thing that's worth pointing out is that, some of this land that they're enrolling, it has actually been clear-cut pretty recently. And so, this is why they needed to do the gerrymandering in the first place. I want to point out that the trees that they left behind are not additional because they left them behind, right? And so there's no justification in having those in a carbon project because they already survived the apocalypse. They're already safe. The trees that they enrolled, the trees that they clear cut, these little areas with like barely anything, those are also not additional. Those should also not be getting credits. And the reason for that is that they went and clear cut this land. Those trees are going to grow back no matter what. Any timber company on Earth is going to let these trees regrow to a point where they can harvest them again. And so really, what we're looking for are people who are preserving forest that was at risk. And if it's at risk, that means that the trees are either big enough to cut down or are in a place that you would want to cut them down. Neither can be said for the vast majority of trees on this project. All right, so let's get into the actual review because we can just circle around forever looking at their absurd boundaries. I guess we'll start with the project satellite data. I apologize, the satellite data was fiercely difficult. This is an extremely wet part of the world. In fact, it's got like more rainfall than like almost anywhere outside the tropics. But essentially, what you see going on here is that the land was more or less all clear-cut in the 90s and early 2000s. So, we're starting here in the 80s. We've got full forest cover, more or less. A couple of areas have been clear-cut. As the time progresses, if we deal with the fact that there's some issues with the satellite imagery, you can see that they more or less did away with all their trees. This is, of course, a zoomed-in, area of the project because you can't look at the whole Alaskan panhandle and get a good picture of what's going on here. So I zoomed into one of these chunks. All right, so that's the summary, and you're welcome to depart now unless you want the deep dive. So what's the deal with this project? It's a 67,000 hectare project. Like I said, it's basically it's an IFM project. It's in the Alaskan Panhandle. One thing that we really have to note here, I provide a million of these pictures. One thing that I think we need is a little background to understand what's going on with this project. The company that owns this project, Sealaska, is a private company, but it dates back to 1971. And what happened in 1971 is the Alaskan Native Claims Settlement Act was passed by Congress. And what happened there is that, people got together in the 70s and realized that, the Native American populations of the region were really disenfranchised and were really given the raw stick, and the U.S. government had basically stolen all of their land. And so in 1971, the federal government basically gave back a whole bunch of land. One of the difficult things about this is that when they gave back that land, the federal government stipulated that the land can't just go back to the Native American communities. The land had to go to private timber companies. And so what happened was the Native American communities all formed a bunch of private timber companies that, although the majority of the stakeholders are Native Americans, the goals of these private timber companies are, to maximize profit from timber. This is very unfortunate, and one wonders, you can get very cynical about why the law was written that way and why they couldn't just give the land back to the communities themselves. But, what happened then over the next 50 years was that these timber companies devastated the land. And there were very few Alaskan Native community timber companies that didn't just immediately cut down all their trees. And that's very unfortunate. But that's kind of the state that we're in right now. And so the remaining trees are on the landscape are largely inaccessible. You know, these are trees that the company hadn't gotten around to yet. They were inaccessible, you know, because they were, well, let's go through some of the examples, right? You know, we've got deep ravines here. We've got trees along coastlines. We've got individual cases of basically trees being circled. We've got tiny islands that nobody is finding financially profitable to bring a barge out there and cut down 12 trees on that island. You know, again, we've got basically these coastline buffers that are kind of, if not required, maybe kind of required. They want to play it safe. They don't want to be fined, so they're leaving a handful of trees along the coast just to be sure. You know, in some cases, this project area is so skinny and ridiculous that, you know, we're talking about a couple of meters. You could hold out your hands and be inside and outside the project on both sides at the same time. So this is the most aggressive form of, you know, basically gerrymandered cheating that you can think of. So that's the situation, and that's why the project's fundamentally unadditional. Let's go through the additionality. So the project, you know, all the paperwork is there, Section 1.1. Section 1.2 is the gerrymandering test. We have a formal test that tests the project's circularity. It goes from 0 to 1, and a 1 means that the project is, you know, kind of a perfect square, and a 0 means that the project is, you know, infinitely squiggly, and this project scores a 0.019, so it doesn't do so well on the circularity test. You know, this is the ratio between the perimeter and the area, basically. You know, like I said, this gerrymandering is because of the way the CARB protocol works, and the protocol is written, the spirit of the law is written well, and I agree that we should not be we shouldn't be giving carbon credits necessarily to projects that have been, like, completely clear-cut, but, you know, this is what happens if you write a rule like this and then don't think through the consequences and have some sort of, like, check. Yeah, I guess it's also worth noting the project developer here is Finite Carbon. So there you go. The owner is the Sealaska Corporation. That basically is a timber corporation that manages the land. A bunch of it's basically indigenous community land. Most of the people in the corporation, most of the stakeholders of the corporation are indigenous community members. So, you know, this is kind of why this happens. Like I said, there's two major problems with this. First, the trees that they left behind are not additional because they already survived the clear cutting and they were inaccessible. And second, you know, this area has a history of exploitation. You know, the forest areas that were clear cut that were enrolled were probably going to grow back anyway. So essentially, this project is incentivizing exploitative timber practices. So we really don't like it. I guess one thing that's also worth noting is that some of these areas here are, we cover the steep ravines and stuff, but a lot of these areas are just too steep to access in general. So I think there are definitely portions of this that are basically like cliff sides, like these kind of things. Like they're not getting at these trees because it's just like a logistical nightmare to cut these trees down. Okay, so that's the additionality issue. And like I said, the reason that we refer to this as cheating, and partially because, we really have a low tolerance for BS at Renoster, but also because this is clearly an intentional act to get around the spirit of the law written by the California Air Resource Board. And so, being an intentional act, this is cheating. So Section 1.3, does this project take place in an area with plausible history to suggest timber harvesting was likely to take place? We leave this one kind of up to you, because in a sense you can argue no, like timber harvesting is not going to take place in a large majority of these areas. Some of these areas were left behind that they probably hadn't gotten to yet. So like timber harvesting in this area is plausible. Clearly, they have every desire to cut down as many trees as possible, or at least they did up until very recently. So that's kind of why it fails the gerrymandering test, but still kind of gets the, plausibility test. The idea here is we don't want like the Nature Conservancy or some conservation organization enrolling land that just had no chance of being clear cut. That's clearly not quite the case here, because these guys have no, they've got no scruples against just clear cutting all the trees off their land. So that's why that rule is there. So next we move on to the baseline. How does the baseline work? Well, I already kind of hinted on how the baseline works. The way that it works with CARB projects is that there's a regional average, and your baseline isn't allowed to duck below that. Besides that, you're allowed to essentially model how you would cut the forest. So you run a series of like FES growth models to basically say, like, this is what I would have done to the forest. Now, on some protocols that don't have this constraint of this regional average, you'll see people just saying, we're going to clear cut all the land. Maybe these guys would have done that. But they do have this constraint. And so basically their baseline is the regional average. They basically say, if the project didn't exist, we would cut all the trees down to what is the common practice, the regional average number. And so they did model it out, but essentially their baseline is just this dotted line right here. And what that means is that they are saying that their above ground carbon is going to go from 167 down to 123 tons per hectare. Now we've already described why. Well, all right. So that's kind of how it works. We do not find this to be a plausible baseline. Because again, we feel that they had every chance in the world and every desire to cut the majority of the trees on this landscape, and that they did, and that the bits that are left to be enrolled are either bits that were just clear cut, fairly recently, and should be growing back no matter what, or bits that they were not able to actually get to. And so, once again, we do not find this baseline to be plausible. We don't find their carbon numbers to be plausible. And what I mean by that is that, yeah, they have 167 tons of carbon on their land, but, their land is only being counted for these red areas, right? And if you actually count the ownership, if you were to actually draw a line around the Sealaska Corp's, land ownership, they would have a lot less carbon. And so just fundamentally, the idea that they've got like more carbon than the average is just ridiculous. They don't have more carbon than the average. They have way less carbon than the average. They should not be getting credits until these trees grow back. And that's decades from now. So we find their baseline fundamentally implausible. But, again, at Renoster, we care more about the numbers. I'm not here just to judge qualitatively. We have our own baseline to see what's going to happen. And so, we run our own baseline and we see what our outcome is. And the ratio between our baseline and the project's baseline is 0, which is kind of a reaffirmation that we've got a nonsense project here. The way that this works is that, we look at the differences between what we say was going to be lost and what the project said was going to be lost, and we, come up with a ratio of that. Well, what we say was going to happen on the project is that not much of anything was going to happen on the project. And our baseline is spatial, but, basically what we say is going to happen here is that in the areas in which they've enrolled the trees that were already preserved, we do not think these trees are at any risk. So the way that our algorithm works is it's going to match these areas to other areas on the map that have a similar history. And if other areas on the map have never been disturbed, and these areas have never been disturbed, then it's going to, basically follow those matches and say, oh, all right, well, areas in which trees were never cut down are not likely to be cut down. And so that's how you end up with a baseline that doesn't forecast much disturbance in these areas, even if there's big trees, because there hasn't been any disturbance in the past. Okay, so that covers these areas. What about the other bits of their project? The bits that cover the recent clear cuts like we saw. Well, once again, our baseline is going to match these areas to areas that have a similar history and a similar situation. And those areas, the most likely outcome for this section of forest right here is that it's going to grow back. No timber company is just going to go and weed whack every year. Every timber company is going to let the trees grow back before they cut them. And so, in a situation like this, our baseline is actually going to be positive. And so the two situations that we find ourselves with this project is that, in the bits of the project where the trees were never at any risk, our baseline is flat, and in the bits of the project where the trees were always going to grow back, our baseline is going up. So what our baseline basically does is pretty close to nothing. It goes up by a tiny bit. And what we're saying here is that we don't think the project should be getting any credits at all. We think that the growth that's happening on this project was going to happen anyway. We think that the conservation that's happening on this project was clearly going to happen anyway. Now, this is the project's baseline in red. Now, this looks different than the figure I showed you up here, right? Well, remember what I said. In reality, the project's baseline is just this dotted line. They use this simulation. I don't even know why they go through the effort of doing these simulations. But the simulation is there. But they're not getting credits issued based on this simulation. You just run the simulation to see if your numbers match the regional average, and then you get all your credits up front. And so that's how the CARB protocol works, in that these projects get all of their credits for avoided emissions on day one. And so this project got about 11 million credits on day one, and then their baseline is just a flat line on the average, and going forward. So that's the situation. And the way that the baseline ratio equation works is that, if our baseline is 0, then we're taking 0 and we're dividing it by a big number, and therefore our baseline estimate is 0. The ratio between our baseline and theirs is 0. So we think that there's really nothing going on here in this project. We use this kind of matching approach. It matches to areas outside the project that have kind of similar conditions. Of note, I think in this project, all these orange areas are matches. The yellow areas are the project area. You really can't tell what's going on here because we're so zoomed out. We're at ISS levels of. We don't match within areas that are owned by the federal government. So that's why you see these kind of hard lines going on here. This is Tongass National Forest, and these areas will not be matched. We're only matching to areas that have a similar ownership, or at least we try our best to do that. Can't always guarantee that we miss every park, but I think in this case we got the parks. So, the matches, as is typical, fall outside the project. Some of the matches fall within the actual ownership of the Sealaska Corp. I think that's something that's worth dwelling on, actually. We don't have the ownership boundary of the Sealaska Corporation. We can infer it. You can look at this area and you can say, all right, it seems as if the Sealaska Corporation probably owns this big chunk of land, which is what I've done here. This red outline is my guess of where the Sealaska Corporation owns their land. But really, they should have enrolled their entire land ownership. And protocols that have, there are protocols out there that have thought this through, and essentially will punish you if you don't include, if you don't consider what's going on outside of the project area but inside of your ownership. This is not one of those protocols. This is just a flaw in the California Air Resource Board protocol. But clearly, this is the area that they should have been being credited for, and they wouldn't have received any credits for the first 30 or 40 years if they had actually enrolled their land like they kind of should have, like the system is supposed to work. All right, so we did the baseline here. Let's talk about leakage. So CARB uses a blanket 20% leakage discount factor, which is pretty aggressive. That's pretty conservative. So yeah, that's to be liked. Honest to God, I like this approach better than I like Vera's approach of this super complicated reference region nonsense. 20% is always higher than the leakage that you end up with the super complicated leakage belt nonsense. But the number is kind of arbitrary, but it is pretty high. But what do we find for leakage? Well, what we find is that deforestation has in fact increased since the project began in the areas outside the project. What does that mean? Well, let's think this through. The areas outside the project are by and large owned by the Sealaska company. They are either national forest and thus not being counted, or they're areas that are owned by the Sealaska company. And so I think a strong argument could be made that this slight increase is genuine leakage, that the Sealaska company might really be harvesting their land a little bit more than they were before now that this project takes place. That is speculation, because I don't know who owns what. I have no idea, because again, like, I don't have the ownership. I just have the project area. I don't have the ownership of like the Alaska Panhandle at my disposal. So there is this increase. There are a couple ways that we might want to look at this. So we've got this increase on the one hand. Maybe that is leakage. On the other hand, is it really leakage? Because we've already talked about how this project is kind of just not additional, and it's not really taking any timber off the market. And the Sealaska company really probably isn't going to be able to actually harvest this timber. And so, is it leakage then if this isn't really having an impact on their bottom line? Maybe it's not. So this is a complex situation, taken collectively. There's mixed signals on the leakage issue. But here's the thing that I want to say. Other protocols, I think, like California, not California support, Climate Action Reserve, for example, will force you to consider the rest of the ownership of the person, the project proponent. And so another protocol that was more conservative in this regard would force the Sealaska company to submit their entire ownership area and then look at the deforestation rate in that whole area. And clearly, that is what should be done here to assess leakage. Renoster can't do that because we don't have access to these private files. But CARB just didn't think of it when they wrote their protocol. But clearly, that is how leakage should be being assessed here. And so we've got these mixed signals, and this is where to go. The other big question is 20% is pretty stiff. So even if there is leakage of like 0.2% or something, then it's probably not making up for the amount of credits that are being taken away from them. All right, so that's leakage. Kind of a complex situation, but probably mostly okay. Okay, because the project has no additionality. Let's talk about verification. So, are the project's carbon numbers correct? Yes, we think so. They do a very exhaustive field inventory. This is one of the areas where the CARB protocol shines. They really require you to slog about on the ground and measure every little twig. The project has a confidence interval of about 9%, and that's just fine. They've got an exhaustive inventory with a lot of plots. They use a set of allometric equations that are used by the federal government, so we approve of that. Actually, maybe they use the Alaskan version, but anyway, they use an appropriate set of equations. The last section in this verification is a catch-all section that we use to say, does the project engage in any unethical manipulation? Well, I mean, I didn't want to say no on this one, because obviously they do. So there, yeah, I'm calling them out for gerrymandering for like the third time. Let's move on to permanence. So, what has happened to the forest cover of the project? The project really hasn't lost any appreciable amount of forest. The Sealaska company has made it clear that they do not intend to harvest these trees ever. Only something like Global Forest Watch only says like 71 hectares have been kind of lost. 71 hectares out of 67,000 is nothing. It's just statistical noise. Our own models say that the project's forest cover has increased. Now, we're only looking at forest cover here. We're not looking at biomass changes. One reason for that I didn't mention up in the baseline bit is that, Renoster uses a satellite called JEDI to basically track biomass change. We don't have to get too much into how we do that relationship here, but essentially we want to tie the relationship between this JEDI satellite's estimates of biomass with an imaging satellite's estimate of biomass. Well, the thing about JEDI is that it's an equatorial circling satellite, and so the maximum latitude that JEDI actually hits is about here. So JEDI is actually just out of range, which means that our models have a degraded performance, and that just kind of is what it is. What we're doing right now to make our baseline and to make these estimates of forest cover and stuff is just using the optical satellite. I don't think that's necessarily, like, I talk a little bit about the pros and the cons of this up above in the baseline section, but it's just something to note. But the relevance here is that while we are able to say forest cover differences, and the forest cover has remained pretty stable throughout the project, we're really not able to say how much growth there's been. But I do want to say there has been growth on this project, undoubtedly. I mean, a lot of this project area, again, this project consists of two types of areas. You've got areas of old forest, I don't want to say old growth, maybe old growth, that were not at any risk, and you've got areas of super young forest that were clear-cut and are now growing back, right? And so the clear-cut areas are going to keep growing, and the old growth areas are pretty much going to be stable, which means that this project is going to be sucking carbon out of the atmosphere. So there is growth happening inside this project, but I want to be completely clear. The growth that is happening inside this project is not additional. So even the removals credits that this project is being issued are not genuine offsets. And the reason for that, again, is that these trees would have grown back no matter what. Normal timber practices would have had these trees grow up to a regional average and then a little bit above, and then they would have cut it down. And so any amount of growth that happens between now and the regional average always would have taken place. And so again, there is no credit from this project that is really additional or valid unless you want to start like poking around and seeing like which of these areas are actually like being preserved that wouldn't have been. Which is far beyond, my capacity or really desire. I don't want to go sorting through like the tiny islands and seeing which ones were likely to be cut. They cheated. All right, like there's no second chance. Like there's no reason to like spend the rest of my life going through their project area, giving them second chances, seeing that like 10% of the credits are valid. This is a CARB project, so it's a 100-year project, which means it's got 94 years left. Or it started in 2015, so there you go. What is the fire risk of this project? There's essentially no fire risk. Renoster's own probability estimates with our own fire risk model puts the fire probability at like basically zero. This is an incredibly wet area, so it remains moist throughout the year. It receives like the most amount of precipitation anywhere in the United States except for like one little area in Hawaii. So there's just like really not a chance of fire. The other thing to point out with this project is that it is really, really spread out. And so there is no scenario when any natural disaster is going to wipe out the majority of the trees on this project. Fire can strike this little bit. And if it were to strike this little bit, it might burn up this mountain a little bit and burn up this little puff of trees. But that is such a small amount of this project that we really can't consider fire to be a substantial risk at all, even if the fire probability was higher. So fire is just off the table. Don't worry about it. That kind of goes for the other risks as well. So I talk a little bit about flooding. It sounds crazy, but tsunamis happen in this part of Alaska. It's a 100-year-long project. Tsunamis kind of happen with that regularity. There was a tsunami in 1964 that caused an 8.4 meter high tsunami, which would certainly wipe out a portion of the carbon stock. Again, I don't think a tsunami is likely to strike this entire region. They tend to be, buffeted by the topography. But it's something I just wanted to put out there. Insects. There are some insects that chew on the types of trees that are in this project. The two most dominant trees are Sitka spruce and western hemlock. Sitka spruce, there is an invasive spruce aphid that has caused some fairly major outbreaks. It's been a long time since the last outbreak hit the Alaska Panhandle, 1997. Maybe you could argue that means they're overdue. Maybe this is not as big of a bug problem as as some other types of bug. It's certainly not like mountain pine beetle like levels of danger here. And there's some question about whether or not these insect outbreaks are going to get worse with climate change. But overall, I think not only is insect outbreak likelihood pretty low for any given area. Again, like insects are not going to hit the entire Alaska Panhandle. They're just going to like hit little portions of it. So again, because this project is so spread out, that's a real insurance buffer. Drought isn't a problem at all. again, the western hemlock, there's a blight and an aphid that can occasionally be a problem. That's even less of a thing than the spruce aphid. The project's own risk for insect damage is 3%, which strikes me as being a little excessive. They get 3% fewer credits because of this. And I have a hard time believing that 3% of the trees are going to get killed by the spruce aphid. But anyway, it's possible, I guess. We overall rate natural risk to be very low for this project. So let's talk about the final score. The final score is 0, right? Like, for one thing, this whole additionality section 1, any failures on that means that you have a fundamentally flawed project and you will always get a 0. Beyond that, the project would actually still score a 0 based on just the algorithm, because the algorithm forecast that these trees were never going to be at risk. And if we zoom to the baseline again, this baseline is positive. So all the credits that are being issued from this project, we think, were already going to be sequestered. So regardless of how you look at it, from either a pass-fail, is this project justified, or a this is what would have happened and this is how many trees were going to be cut down, we still come to the conclusion that this project's it gets a 0, that none of its credits are valid. Or if there are some, I would assume that it's a very small margin. Some statistics, I guess we kind of talked about some of these. The project's been issued with 11 million credits, so it's a really big project, and it's quite upsetting to see this many credits on the market. Or I'm sorry, it's been issued with 12 million credits. 11 million since they got 11 million up front for being over the average, over the regional average. The remaining million have been based on growth, and again, those removal credits are not additional either. They would have grown back. The other thing that's important to note is that I guess the project is made up of 410 separate, disconnected little areas. So that is gerrymandering to the extreme, and it's quite upsetting to see this many credits going on the compliance market, no less, right? So this is, the last section is kind of a more qualitative section that discusses ecological and community co-benefits. In terms of ecological benefits, we don't think there are many, and most of it, the reason comes back to the project not being additional. Fundamentally, if the trees were always going to be preserved, it is not fair to credit the project with ecological benefits if, these little trees inside of the ravines were always never going to be cut down. So there's that whole concept. There's an enormous amount of PR surrounding this project, which is very frustrating. You have to a lot of it is just hot air, right? They talk about how they're halting logging on the project, okay? They talk about how, as a company, they value, good land stewardship and stuff, which is obviously nonsense, because, again, the areas around the project are just bombed out. Clear cutting is their favorite thing. So there's all that. The majority of what we think is the Sealaska ownership was clear cut in the 1990s, with some taking place a little before and a little after. So again, a lot of the area is not additional, so you ain't getting no kudos for that one. Another thing that we have to touch on is that forest fragmentation is notoriously bad ecological habitat for most species, right? And this is a highly fragmented forest. The forest is just as fragmented as the project itself. And what this means is that, rare and endangered species, especially larger animals, that really need a large area of contiguous land to roam, don't have access to that. And so even the forest itself is because it's so heavily degraded and because there's an edge so nearby, the forest itself is suffering. And there's a number of reasons why that's the case. Forests that are closer to the edge, that have higher wind throw, they have lower biodiversity, they have fewer plant species, they have fewer animal species that are able to take advantage of these little corridors. So, fundamentally, just the idea that these little patches are being preserved is just not enough for a lot of the important animals that are out there. So we don't give this project much of any credit on the ecological co-benefits side of things. I think on the community co-benefits, we do have to give them some credit. The Sealaska Corporation is a for-profit corporation, but it is responsible. It is kind of like joint owned by 23,000 Native American shareholders. So this money kind of does make it back to the Native American communities, albeit obliquely. Beyond like shareholder distributions, Sealaska has a couple of like other programs. So they provide scholarships. They built a couple of schools and community centers. So they do some good things for the communities that they sprung from initially. The project allows for kind of more community-driven use of the land. So single tree removals for cultural events. Canoe making, for example, or totem poles. Also, traditional hunting and fishing are allowed on the land, and so these are positives. These are definitely community positives for the land. Overall, I think it has a positive community benefit. It is worth remembering that these communities are enormously. They've been really disenfranchised in the past, and they're often very impoverished and. They really deserve more support from the U.S. government and whatnot. And it really sucks that this 1971 Act, put this in private hands, even though at least it is in the hands of private Native American communities. So I think it's fair to say that the project definitely has a positive impact on the impoverished Native American communities of the Alaskan Panhandle. That said, does not excuse the project from this blatant cheating. That's just not okay. It doesn't really matter if the communities are benefiting from the money. What matters is that real pollution is being offset with these credits, and the credits are not genuine. So that's another happy Renoster review. Thanks for tuning in.